All right, let's talk about something we use every single day. GPS. We use it to find a coffee shop, navigate a new city, maybe even track our runs. But have you ever actually stopped and wondered, how does it work? The genius behind it is absolutely incredible. I mean, really, think about it for a second. You pull out your phone, you open up a map, and boom, this little blue dot just appears. It shows you exactly where you're standing on planet Earth. How in the world does that happen? It seriously feels like magic. But you know what? The reality is way cooler. The secret here isn't some single, brilliant trick. Nope. It's a massive, coordinated effort. You can think of it like space teamwork, happening on a global scale every single second of every single day, all just to put that little dot on your screen. So, to really get this, we first need to meet the team. These are the real unsung heroes of our digital world, constantly flying way, way above our heads, completely invisible to us. That's right. There are currently 31 active GPS satellites whipping around our planet in orbit. It's this whole constellation that's carefully maintained by the U.S. Space Force. And they're set up in such a way that no matter where you are on Earth, you can see at least 4 of them at any given time. And that number, 4, is going to be super important in just a minute. So what's their job? Well, it's beautifully simple. Each satellite is basically a ridiculously accurate clock in the sky, an atomic clock. Its main job is to just constantly broadcast a simple signal. All that signal has is 2 pieces of info, the satellite's name, basically, and the super precise time it sent the signal. That's it. They are just shouting the time, over and over, with precision down to the nanosecond. And that simple little timestamp is where all the magic really happens. Because your phone, the device in your pocket, is smart enough to turn that piece of information about time into a measurement of distance. Let's break down how it does that. The big sciencey principle at play here is called trilateration. Now, I know it sounds complex, but the idea is actually super simple. If you know how far you are from 3 different spots, you can figure out your exact location. And in our case, those known spots are the satellites flying around in orbit. So how does your phone figure out the distance? Well, it uses this super fundamental physics equation you probably remember from school. The speed part is easy. That's the speed of light. It never changes. The real trick is figuring out the time. You know, how long did it take for the satellite signal to actually get to your phone? Your phone does this in a flash. It hears the signal, it looks at the timestamp of when it was sent, and then it compares that to its own clock to see what time it arrived. That tiny, tiny difference between those 2 times, that's the travel time. Multiply that little number by the speed of light, and bam, your phone knows exactly how far away it is from that one satellite. But here's the thing. Knowing your distance from just one satellite isn't really enough. This is where the teamwork really kicks in. This is the part where it all comes together. Okay, so let's say your phone figures out you're 12,000 miles from satellite A. That's great, but where? You could be 12,000 miles in any direction. What that means is you could be anywhere on the surface of a giant imaginary sphere, with that satellite right in the center. We've narrowed it down, sure, but not by much. Okay, now a second satellite signal comes in. Your phone does the math again and figures out it's, let's say, 15,000 miles from satellite B. Now we have 2 of these giant spheres, and where they overlap, they intersect to create a perfect circle. So you're not on a giant sphere anymore. You're somewhere on that one specific circle. We're getting much closer. And here comes the third teammate. Your phone calculates its distance from satellite C. The sphere from this satellite intersects our circle at exactly 2 points. So now we know you're in one of just 2 possible spots on the entire planet. We are so, so close. And this is the final crucial piece of the puzzle. That 4th satellite signal isn't just for backup. I mean, your phone could probably guess which of the 2 points is right. But the 4th signal confirms it. But it does something even more important. See, the satellites have those perfect atomic clocks, but your phone's clock is, well, it's not perfect. That 4th signal lets your phone fix its own clock error, syncing it up with the satellites and giving you that pinpoint laser-focused accuracy. And that's it. That is your little blue dot. When you really step back and think about it, it's just a staggering achievement. This invisible web of information connecting us down here on the ground to a whole team of helpers up there in the sky. So the next time you look at that blue dot, just remember what it really is. It's not just a point on a map. It's the end result of a constant, high-speed conversation between the device in your hand and a synchronized team of atomic clocks orbiting thousands of miles over your head. This system runs our navigation, our shipping, our emergency services, even global financial markets. This invisible system truly holds our modern world together. And it kind of makes you wonder, what would happen if one day that conversation suddenly just stopped?